In the late months of 1944, Japan faced mounting pressures on multiple fronts. Industrial centers and supply lines were increasingly targeted by Allied bombers. Military leaders sought unconventional methods to disrupt the American war effort across the Pacific. One proposal involved the use of hydrogen balloons to deliver explosives to North America. Engineers calculated trajectories using the jet stream to carry balloons across the Pacific Ocean. Each balloon would float at high altitude, traveling thousands of miles over weeks. The objective was to ignite forest fires, destroy crops, and create psychological impact among the civilian population. Design teams worked in secrecy, crafting the balloons to maintain altitude and stability for extended flights. Each hydrogen balloon measured more than 30 feet in diameter when fully inflated. Attached to the balloons were small mechanical altimeters to release sandbags and ballast, maintaining proper flight level. Explosive payloads were mounted with timers to detonate after crossing the ocean. The balloons were designed to be resilient enough to withstand storms, frigid temperatures, and high winds over thousands of miles. Testing and calibration consumed months of work and thousands of man-hours. Launch sites were constructed in remote areas of Japan to avoid observation by Allied reconnaissance. Teams practiced inflating hydrogen cells, monitoring pressure, and calculating release sequences. Engineers monitored weather patterns, carefully choosing launch windows with optimal jet stream conditions. The campaign was highly secret, and few outside the Imperial Army were aware of the project. The first full-scale launches began in late 1944. Balloons were released singly or in small groups from coastal sites. They rose silently into the air, propelled by the buoyancy of hydrogen and guided by programmed altitude control. Each balloon carried between 300 and 500 pounds of explosives. Smaller incendiary devices were included to ignite fires in forests and rural farmland. The goal was not large-scale destruction but disruption and fear. American intelligence initially had little knowledge of the program. Reports of strange objects falling in the Pacific Northwest were sporadic and dismissed as isolated incidents. Weather observations sometimes noted unusual high-altitude objects, but their purpose remained unclear. Despite the secretive nature of the campaign, thousands of balloons were launched between 1944 and 1945. Each balloon drifted thousands of miles under the control of altitude mechanisms, designed to maintain position within the jet stream. Survivability depended on careful calculation of ballast release and detonation timing. For weeks, American radar and civilian reports did not detect the majority of the balloons. Some exploded over the ocean unnoticed. Others reached the west coast of the United States and Canada. A small number caused minor fires in forests or damaged property in sparsely populated regions. The program relied on both physics and patience as balloons moved without guidance systems. Engineers in Japan tracked weather reports to optimize launch dates. Even a slight error in timing or weight could cause a balloon to descend prematurely or fail to reach the target area. Each successful launch represented months of engineering and meticulous preparation. The Imperial Japanese Army referred to the project as Fugo Balloon Offensive. They believed it could impact morale and divert American resources from the front lines. From the American perspective, the first confirmed incidents of balloon bombs were initially treated as curiosity. Farmers reported fires in remote forests or unexplained explosions. Military authorities began investigating the pattern once multiple reports aligned along the west coast. The balloons became a subject of concern, as they could not be reliably intercepted by aircraft or anti-air weapons. The lack of precise guidance made them unpredictable, but also difficult to neutralize. The initial campaign set the stage for thousands of additional launches. Engineers continued refining balloon construction and payload mechanisms through early 1945. They experimented with altimeters, improved ballast systems, and lighter weight materials to extend flight duration. Each iteration increased the chance that balloons would reach North American targets. The combination of scientific calculation, secrecy, and high-altitude engineering made the program one of the most unusual methods of long-range attack in history. The psychological effect was intended to be significant. Damage remained limited. By early 1945, reports of unusual objects and explosions began appearing along the west coast of the United States and Canada. Farmers, hikers, and forest rangers discovered burned patches in forests and debris scattered across remote areas. At first, authorities were unsure whether the incidents were accidents, natural fires, or intentional attacks. Investigations revealed fragments of balloon material, aluminum tubing, and paper remnants consistent with high-altitude craft. The scale of the launches became apparent as dozens of balloon incidents were documented over the next several months. Most balloons carried incendiary devices designed to ignite fires upon landing. Explosive payloads intended for destruction were relatively small but still capable of igniting significant forest fires under dry conditions. The balloons drifted silently over the Pacific Ocean, propelled by jet stream winds. Many traveled thousands of miles without detection before reaching populated or forested areas. The lack of guidance made their landing unpredictable and dispersed the effect across hundreds of miles. American military authorities mobilized to investigate and mitigate the threat. Forest rangers were instructed to monitor for unusual fires and report unexplained explosions immediately. Communities were alerted, but detailed information about the nature of the threat was limited to avoid panic. Radio broadcasts and newspapers issued warnings about the balloons, describing them as high-altitude incendiary devices. Despite warnings, many balloons remained undetected until they landed or exploded. Incidents ranged from minor forest fires to small property damage in rural areas. One incident in Oregon resulted in the first known fatalities from the balloon program. A pastor and 5 children were killed when they encountered a live incendiary device in a forested area. The tragedy reinforced the seriousness of the threat. Military authorities instituted strict protocols to suppress public reporting and avoid revealing information that could aid Japanese intelligence. Engineers in Japan continued launching balloons with adjustments to improve flight duration and altitude stability. Some balloons traveled for more than 1 week over the ocean before descending over North America. Weather conditions such as storms, wind shear, and jet stream fluctuations affected the trajectory of individual balloons. Not all reached the continent. Many fell into the ocean or exploded prematurely at high altitude. Those that landed in remote forests sometimes ignited fires that burned for hours before detection. American military and civil agencies worked to suppress reports and quickly extinguish any fires caused by the balloons. The unpredictability of landing locations combined with high-altitude flight made interception extremely difficult. Radar coverage at the time was limited to coastal areas and could not reliably track lightweight hydrogen balloons. Air patrols were mostly ineffective because the balloons were dispersed across thousands of square miles and traveled at high altitudes beyond the operational ceiling of most fighters. As a result, the majority of balloons reached the continent without being intercepted. Authorities emphasized rapid response procedures to contain any damage. Firefighting units and rangers were trained to identify incendiary materials and neutralize them safely. Each recovered balloon provided valuable insight into the design and construction used by Japanese engineers. Intelligence teams documented altimeter mechanisms, ballast release systems, and explosive payload arrangements. The analysis allowed the military to understand how many balloons could be in flight at any given time and predict potential landing zones. Despite the limited physical destruction, the campaign achieved its intended effect of psychological disruption. Civilian communities were aware that foreign explosives could arrive without warning from across the Pacific. The threat forced resource allocation to fire monitoring and rural protection, measures that diverted attention from other priorities. By the end of 1945, over 9,000 balloons had been launched across the Pacific Ocean toward North America. Only a fraction caused significant fires or damage, but every launch represented months of engineering work and thousands of man-hours. The Japanese balloon program remains one of the longest-range unmanned weapon campaigns in history. As the balloon campaign continued over North America, officials began documenting the physical and psychological impact. Most balloons landed in remote forests or mountainous regions where damage was limited. Some started small fires that were quickly extinguished by rangers or natural conditions. A few exploded near farms or rural properties, causing minor structural damage. The majority of the population remained unaware of the specific threat due to government suppression of information. Officials feared public panic if the full scope of the launches was revealed. Military intelligence focused on analyzing recovered balloon fragments. Pieces of aluminum tubing, paper panels, and partially burned wiring were collected. Analysts reconstructed the altimeter and ballast release mechanisms to understand the flight patterns. They discovered that the balloons were engineered to maintain altitude using sandbag ballast that was automatically released at predetermined levels. Explosive and incendiary devices were mounted on wooden frames designed to release safely while keeping the balloon airborne. The program demonstrated remarkable engineering for its time. Hydrogen cells had to remain intact for days at high altitude, while compensating for temperature changes and wind currents. Weather forecasts and jet stream data were carefully tracked to anticipate when and where the balloons might reach North America. Despite the sophistication of the design, the effects on the ground were limited. Only one confirmed instance resulted in civilian deaths. Several fires occurred in forests, but most were contained before spreading extensively. The campaign did create disruption and uncertainty. Rangers and firefighting units had to remain vigilant, constantly patrolling areas to detect unusual activity. The psychological effect was significant even though material damage remained low. Communities along the west coast became aware that objects could arrive from thousands of miles away without warning. Officials continued monitoring and cataloging every recovered fragment. Technical analysis of the balloons helped improve American countermeasures and informed civil defense planning. Engineers understood the flight limitations and failure points, which allowed predictions of likely landing zones. Military authorities implemented training for rangers and local response teams. Safety protocols were established for handling live incendiary devices. Coordination between local authorities and federal agencies improved response time and reduced risk of injury or fire spread. Despite these efforts, the balloons continued to arrive sporadically until the end of the war. Each recovered balloon added to knowledge about Japanese engineering methods and strategic planning. The campaign illustrated the potential and limitations of long-range unmanned attacks. Although thousands of balloons were launched, only a fraction reached populated areas. Physical damage was modest, but the scale of effort involved highlighted the resourcefulness and persistence of the Japanese military. By analyzing the flight trajectories and recovered devices, American intelligence could map potential paths and estimate timing of arrival for future launches. This allowed targeted monitoring and rapid response that minimized casualties and damage. The balloon campaign also revealed vulnerabilities in Japanese logistics. Each balloon required significant resources to manufacture and launch successfully. Weather conditions could easily render launches ineffective or cause balloons to fall into the ocean. Despite these challenges, the program continued in an attempt to create strategic impact. The combination of mechanical ingenuity and high-altitude atmospheric understanding made the program remarkable from an engineering perspective. The results were limited in practical terms, but effective in forcing allocation of resources and creating concern on the West Coast. By mid-1945, the effectiveness of the balloon program had diminished significantly. American authorities had established systematic monitoring and response procedures across the West Coast. Forest rangers, firefighting units, and military personnel coordinated to identify and neutralize incoming balloons. Weather forecasting and jet stream analysis allowed predictions of potential arrival times and locations. Most balloons that reached North America caused minimal damage or were intercepted before reaching populated areas. The engineering of the balloons remained impressive, but the practical impact was increasingly limited. Japanese launches continued until late spring of 1945, but each additional balloon represented diminishing returns. Fuel shortages, material constraints, and logistical difficulties further reduced the feasibility of sustained operations. As Allied forces advanced across the Pacific, the strategic need for diversionary attacks decreased. Intelligence reports indicated that the balloon campaign had not materially affected military production or major civilian activity. Nonetheless, the program remained a testament to long-range unmanned attack strategy and atmospheric engineering. Every recovered balloon provided new data for both American and Japanese technical analysis. American engineers studied materials construction methods and altitude control mechanisms to improve understanding of high-altitude flight. The balloon program was ultimately a blend of ingenuity, persistence, and limited practical effect. By the surrender of Japan in August 1945, the campaign ended. Thousands of balloons had been launched over a period of nearly 1 year. Only a small percentage caused fires, minor damage, or isolated casualties. American authorities continued monitoring and collecting fragments to preserve historical and technical records. The campaign became a case study in the use of unmanned weapons and the challenges of intercontinental attacks without guidance systems. Communities affected by balloon incidents gradually returned to normal. Fire monitoring and civil defense measures remained in place for a time, but the perceived threat diminished. Military historians later analyzed the campaign as a combination of scientific calculation and psychological strategy. The program demonstrated how a nation with limited resources could attempt innovative long-range attacks, despite technological constraints. The end of the campaign marked the conclusion of one of the most unusual and ambitious wartime strategies in history. The Japanese balloon campaign of 1944 to 1945 remains one of the most unique strategies in modern warfare. Over 9,000 hydrogen balloons were launched across the Pacific Ocean toward North America. Each balloon represented months of engineering effort, careful calculation, and secrecy. Despite the scale of the program, only a small fraction caused physical damage or casualties. The majority landed in remote forests or exploded over the ocean unnoticed. The campaign demonstrated the ingenuity of engineers working under severe wartime constraints. Hydrogen cells, altimeters, ballast release mechanisms, and explosive payloads combined to create a long-range unmanned weapon that traveled thousands of miles. American response evolved as authorities established monitoring patrols and rapid response teams. Forest rangers, firefighting units, and military personnel worked in coordination to minimize damage. The psychological effect of the balloon threat was significant, even though physical destruction remained limited. Communities were aware that objects could arrive unexpectedly from across the ocean, creating uncertainty and concern. Recovered fragments provided invaluable insight into Japanese engineering methods, high-altitude flight, and strategic planning. Intelligence and technical analysis allowed American authorities to predict flight paths and improve civil defense measures. The campaign highlighted the limitations of long-range unmanned attacks without precise guidance systems. Weather conditions, material constraints, and the unpredictability of jet stream currents limited operational effectiveness. The program remains an important case study in the history of warfare and technological innovation. Historians note the remarkable blend of scientific calculation, perseverance, and strategic intent that defined the effort. While the balloon program did not change the course of the war, it forced allocation of resources and demonstrated the potential for psychological disruption. The campaign is remembered as a demonstration of ingenuity under pressure and the challenges of intercontinental attack using limited technology. Communities affected by the balloon attacks gradually returned to normal life. Official reports preserved technical documentation of recovered balloons and detailed accounts of incidents. The story of the Japanese balloon program serves as a historical record of innovation, ambition, and the complexities of global conflict. It remains a testament to the ingenuity and determination of engineers and military planners, despite limited practical impact. The Japanese balloon campaign ended with the surrender of Japan and the conclusion of the Second World War. It left a legacy of study for future generations in military strategy, high-altitude engineering, and the use of unmanned long-range weapons.